Hello, so we will be working on number 91 for this video, and that is to let the topology be the set of irrationals, rationals, the empty set, and the real numbers, and we must discuss the convergence or divergence of this sequence in this topology. So, when checking convergence, you would check every number, but of course, as you can see, there are a lot of numbers in the rationals. So I'd like to bring back up my channel of videos, this one. I made a video that I had to cut into two parts because it was too long, that speaks about my understanding of convergence. And within that video, I said there's a simpler way to test what numbers would converge. So let's say real quick, we have the numbers 1 and 2. We'll say that goes from negative infinity to 1. And that'll just be 2 to infinity. So if our sequence is 3, 3, 3, 3 forever, we can see that this sequence only converges to this. So if these are open sets, any number in this open set will have the sequence and therefore it will converge. Whereas this one, if we chose, does -2 converge? This set contains -2, but the sequence does not converge to that. Therefore, it does not converge, or it's written this way, except the sequence does not converge to -2. And that will actually be true for everything in this open set. So this sequence does not converge to this, so anything in this set, because it is an open set, will not be converged to. So that being a quick review, let's look at what our sequence would look like. So our sequence is 1 over n, so we have 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, and so on. So this is a number from 1 getting closer to 0. I mean, right now it's a long way to go, but they'll get there. So, as we can see, all these numbers are rational because they're written as a fraction. So this sequence of 1 over n does not go towards irrationals, and neither is it empty. So now the rationals and the real numbers are contain this sequence. So this sequence converges to these two. So that being said, if I choose a from rationals, no matter what I pick in here, 3.15, 96.5, it's gonna exist in there, and hence I have to check if this sequence converges to it. And this sequence will converge to it because, as I said, these are rational, so it will converge. And likewise, for any number in the reals, if we pick minus the irrationals, I believe they're a subset in the reals. So for all a in the reals and minus the irrationals just to make sure union empty set, well, just to make sure we exclude the empty set. If we pick anything from there, the number would exist in reals, and we would have to check if the sequence converges to the reals, and it also will converge to the reals. So this sequence would only not converge, it'll diverge from the irrationals and the empty set. And if you want to see a bit more of my explanation of how we just check if the sequence is within there, you can check the other two videos. And that is my proof, but like if you want the definition for convergence, it's that there exists an n in naturals such that for all n great for all n greater than or equal to n, 1 over n is in G, and again G would be these up here. So that's true for rationals and reals, but not true for irrationals or the empty set.